Okay, so now we're going to change back into English, and now we are very proud to have the honor of presentation from a woman and from Africa. And both things are not so common in this kind of congresses. And I think that after all the people that have been this morning that have missed some presentations from Sudan, I think that now we have a perfect opportunity to have a good example of recharge study from Egypt as an African country that can give us another perspective from our brothers from the other part of the Mediterranean Sea.
My paper title is Computing Groundwater Inflow Outflow at Lake Karun, Egypt, presented by Rania Abd-El-Baky, Alexandria University, Egypt. Overall, the world managed aquifer recharge project play an extremely important role due to water scarcity. Obtaining water for more depends on many factors. The local water cycle and the human activity in the study area. So, a study of Lake Karun water budget was conducted for more purposes. The objective of this study, number one, studying the local water cycle for Lake Karun for more purposes. Applying the hydrology budget balance for conservation and better management of water resources. Achieving the more objective by the conjunctive use of surface water and groundwater to sustain water supplies. Study area is Lake Karun. Lake Karun is one of the oldest natural lakes over all the world. It is located in the north of the West Desert of Egypt. It is an important place for fishery and salt production, tourism, and the migratory of birds in the autumn and winter seasons. Lake Karun, located in the west part of the depression, Al-Fayoum Depression, at an elevation 43 below the sea level. Al-Fayoum Depression is a green and fertile depression. It has a unique environmental setting. Al-Fayoum Depression surrounded by desert of all sides except the southeastern side, where it connected with the River Nile Valley. The total surface area of Al-Fayoum Depression is approximately 6,000 square kilometers. Approximately 1,600 square kilometers are cultivated land. It is represents 5% of the total cultivated area in the Egypt. Al-Fayoum Depression has a unique topographical feature. It is a mix of desert, coastal nature, and agriculture. Its climate is arid, with a long hot summer and short winter. It has rainfall approximately less than 15 millimeter monthly. The temperature ranged between 14 to 31 Celsius degree. The drainage system of Al-Fayoum Depression depends on two main drains, number 2 and number 3, Al-Bats and Al-Wadi drains, which collect the water from the depression and finally flow in Lake Karun. The water balance equation was applied in its simple form, so we estimate all components of the equation by using meteorological data and Boyne ratio energy budget to calculate evaporation rate, and using meteorological data to estimate rainfall, and flow net analysis and Darcy's law to calculate the groundwater flow. From the archive literature data, we get the pumped water from lake to a missile company to salt extraction. And the discharge water from Al-Bats drain and Al-Wadi drain, which follows in the lake. Groundwater estimation in this study depends on Darcy's law and the flow net analysis. The topographic is the main factor affects the flow rate at the surface. The ground level at El Fayum depression arranged from the 37 meter above sea level to 49 meter below sea level. Soil texture in El Fayum depression consists of sand and clay and loam. The depth to water table for upper aquifer in El Fayum depression arranged from half meter to 1.25 meter. The flow net analysis used as a tool to mapping groundwater discharge and direction. The results of water budget equation is rainfall approximately 15 million cubic meter per year, and drainage water for 419 million cubic meter per year, and the groundwater for 47 million cubic meter per year. These three components represented as inflow water to Lake Karun. But on the other side, the pumped water for a missile company approximately 19 million cubic meter per year, and the evaporation for 104 million cubic meter per year. These two components represent as outflow water from Lake Karun. The storage is 59 million cubic meter per year. The percentage of the components for the inflow and outflow water for Lake Karun. Inflow water represented as 87% for drainage water, 3% for rainfall, 10% for groundwater. And the outflow represented as 95% for evaporation and 5% for a missile company. The residual amount of water balanced equation is 59 million cubic meter per year. This is amount resulted in increasing the water level annually by 25 centimeter and consequently increasing the surface area of Lake Karun. This figure shows the threatened area will be affected by flood. The ISMAR system, the main common source of water for ISMAR are river water or treated wastewater or the storm water. The surface water Lake Karun gain the water from rainfall, drains, and lost water for evaporation in missile company. And the El Fayum depression aquifer receive water from River Nile and excess irrigation water and rainfall. Part of the groundwater from El Fayum depression input to Lake Karun as inflow water. This study suggested to take part of the water lake after making adequate treatment to recharge the El Fayum depression. Using treated water from lake as a recharge water for El Fayum depression aquifer has many benefits, such as to protect and conserve the water from evaporation in the lake, to mitigate the hazardous flow event, to renew the lake water and groundwater, to achieve groundwater and surface water management, to protect the ecosystem, finally to optimize surface water and groundwater resources. Thank you for your attention.
Thank you very much for your presentation. Is any question? Please.
So, what's the salinity of this water? How much salt is in the water? So this water is evaporating a lot, and they're even producing salt from it. So how much the salinity of the water?
Salinity. Salinity has 13 part per million as the water of sea.
And so your goal is to get the water to infiltrate so it doesn't evaporate so much, I guess?
I think that's, isn't it?
Yeah. Sorry.
Salinity in the lake water. Yes.
And I think that he's trying to know if as you are taking much water from the lake inside the Nile, aren't you increasing the salinity in the lake? That could be more dangerous for the lake than positive for the aquifer. I don't know if this is the real meaning of your suggestion.
Yes, the water has salt and has many heavy metals, so we must make adequate treatment before we use water. I mentioned that.
So apparently now what you're trying to reduce is at least to not to lose so much water because of evaporation in the lake, isn't it?
I focus in this study to study the local cycle water for Lake Karun to know it is suitable to make ISMAR or not.
Yeah.
Is water budget say that water level increase 25 centimeter annually. There are a lot of area subject to flood.
Floods, okay.
To protect this area, to protect water from evaporation.
So in this case, they are just something that usually is just the other way around. In other places where we have a lake that is losing area, and usually the problem is that you could be risking the habitat of the lake. In your case, the lake is growing instead of lowering the surface. Yeah. The thing is that usually the things are the other way around in most of the arid areas. I mean, I was going to ask you just something similar in the way that I thought that maybe you were going to have a lot of ecological constraints because of operating in this lake, because, okay, you could be trying not to have such a high evaporation, but at the same time you could be lowering the surface. But I didn't realize that you were saying that this lake, in this case, is going bigger than...
This area is arid, has a long hot summer and short winter.
Yeah, but the lake is still growing and threatening with floods to the cultivation in the area, in the river bank, in the lake bank.
When we subtract again
the water, yeah.
59 million cubic meter annually residual.
Okay, so it's.
Thank you.
Thank you very much for your explanation. I think it's a very outstanding example of something completely different to some kind of problems that we have. But thank you very much for your presence.